So this second video from Chapter 7, Section 1 is going to discuss exponential and logarithmic relationships. Up until this point, you've learned several inverse operations. Addition undoes subtraction. Multiplication undoes division, or division undoes multiplication. In the last unit, we learned that if something's being squared, you can square root it to cancel out the exponent. Logarithms and exponents are inverses of each other. And so it's possible to take something like 8 raised to the x power equals 64 and rewrite it as a logarithmic equation that looks different but means the same thing. The first piece to understand is that the base of the exponent, or the pedestal that holds up the exponent, is always going to be the base of your log. So this number here is the base for your exponent. It's going to come over here and shrink to be the base of your log. So this is stated as log base 8. This is all one piece, kind of like an addition symbol or a minus sign. This is a mathematical operation that you are doing, log base 8. It's not log divided by 8 or log minus 8, it's just log base 8. It's all one big chunk. Then you're taking this log of a number, and that number is going to be, let me get a different color pen here, whatever is on the other side of the equal sign. So the pieces with your exponent are going to be on this side of the equal sign. Anything on the other side of the equal sign, whether that be a number or a variable or a variable plus a number, whatever's going on over here is going to be what we take a log of. And that number is just a normal size number. And then what a log helps us to do is it helps us to pull this x down so it's on level ground with everything and we can solve for it. So what a log equation is always set equal to is anything that is up here in the exponent. It might just be an x, it might be 2 times x, it might be x minus 4. Whatever is up in the exponent comes over here to be on the other side of the equal sign in logarithmic form. So in this case, it would just be an x. Now, both of these equations ask the same question. What exponent do I need to raise my base to get my argument? The word argument is a brand new vocabulary term, and we use the argument to describe the number that we are taking a log of. So log base 8 of 64 is going to be equal to whatever exponent I would need to raise 8 to turn it into 64. So these two equations look different, but they mean the same thing. They're asking the same question. What exponent would I need to raise 8 to turn it into 64? What exponent would I need to raise this base to turn it into 64? And that's what we're solving for. So this relationship we're going to go into more in 7.2 when we start talking about properties of logarithms, where when an x is up in an exponent, we cannot solve for it. We have to pull it down onto even ground so that we can solve for what that number is. Now, of course, this example here is very simplistic. We all know that 8 squared is equal to 64. But they're not always that easy. You might have something like 2 raised to the x power equals 3. Now, we can't do that in our heads. So we would need to transform this into a logarithmic equation. The base of the exponent is always the base of the logs. That's log base 2. Our argument is what we're taking the log of, and that's always what the exponential equation is equal to. In this case, that's 3. That's going to be equal to the exponent that we're trying to solve for. These two look different, but they mean the same thing. Now, in 7-2, properties of logarithms, we're going to learn how to evaluate this logarithm so that we get an actual number that's meaningful so that we know what that exponent would be.